introduction to the sine and the cosine functions. Now, once you've studied sine and cosine, so all the different ratios that you have, maybe even tangents and secants and so on, you slowly, hopefully, will get into trying to map these into basically functions. Now, you have studied quite a few functions in grade 11, right? So you've studied from quadratics, you've studied kind of polynomial functions, you've studied exponential functions, you've studied logarithmic functions, okay, and so on. Now, one of the types of functions you haven't studied was kind of periodic functions, right? So functions that over a particular span have a cycle which then just keeps repeating over and over. Now, the introduction to the periodic functions, I did a video introduction. I'll put up a link up above there for you. And now within here, we want to take the periodic functions kind of to the first initial step of taking them and trying to graph both sine and cosine as functions and not just as kind of ratios from, you know, these triangles that we were working on a continuous basis. So any function that you have always kind of has an input. Okay, so this is your input right here. And for us, the input, I guess, in this particular case is basically the angle that we have, because we're just talking about sine and cosine. So I'll concentrate on sine for the moment. So that input, let's say, is some particular angle that you have, and you want to be able to have as your output, you want to be able to have what the actual ratio, okay, of that angle would be if you were just dealing with the sine function. So that x, which is your input, which we typically stated it as x, and I can keep it as x, but I'll just remind you that you can think of it as theta in terms of the angle that you're trying to map out. That angle is your independent variable, and then your dependent variable becomes your y, which is your output from sine, or, okay, from cosine in this case. Now, when we start mapping these things, I'm going to do a table of values for you, kind of bring you back to the unit circle, which again, from the unit circle, you can see that it's going to be very easy to see that there's a continuous pattern of repeating, okay, over and over those ratios. Doesn't matter how big or how small or if even negative the actual angles become. Now, those angles are going to create for us this periodic function. And because it's going to be periodic, we're going to want to try to map out a few things. So what is the period of this function, right? What's the kind of mid-range? So what's the axes, the equation of kind of the axes, the middle point? What is the amplitude? What are the maximum and minimum values, okay, once we have that amplitude? And what's the domain, okay? And then what's the range for this particular function, like we used to define many other functions? And then are there any crossings, right? And there will be actually crossings that you will see. Those crossings, so those are kind of the zeros that we have of our function. So I'm going to try to map these things out. I'm also going to bring back Desmos, okay, to graph this thing for you. And then you can see that it's a very nice, beautiful wave that continuously is symmetrical and repeats over and over. And it has a cycle, okay, of basically 360 degrees, or just simply 2 pi if you're talking about radians. So let's kind of take a look and go back to this unit circle that we had, right? So what we're saying is, we're saying that, and I'm going to kind of draw out, and maybe I'll put it in orange here, okay? Let's say that we had, and we were creating an angle that was kind of moving along. So this was 30 degrees, 45 degrees, 60 degrees, 90 degrees, okay, 120, and so on. So this angle, okay, and this arc that we're creating can continuously happen. But eventually when you get to 360, you notice that, oh, okay, well now, so I mean, this, if you moved over, so it would have been actually 390 degrees if you take a full rotation around and then come back. But the result is the same, right? So the result for your sine, okay, and your cos is going to be the same if you make the repetitions. So it doesn't really matter how many times you go around here. The values keep repeating after 360 degrees or after 2 pi. So that's what we will have. So now within this, I'm going to take, and again, I'll just concentrate on the sine for the moment. Let me create a table of values, kind of like we did for our input and our outputs. So something like this, so I'm going to state, so here's my input x. Okay, well, I mean, for us, I guess it's the angle. I'll just kind of refer it to x or theta. And then if you create a table of values, so if I'm going to create this, and I keep moving it down here, okay, then my output, so within here, is supposed to be, sine. So I'm going to be trying to find what the sine of x is, or sine of theta. Okay, so sine of that angle for whatever it might be. And, as you start, so let's say you started off with, 0 degrees, okay? Well, 0 degrees in terms of radians would have been just 0. So I'm going to try to write both, okay? Just as you can see on this unit circle, I'll write it in degrees and radians. And by the way, we primarily, when we graph, as you keep going in math, you're going to change those degrees into radians. That's what we actually kind of like to do, but I'll try to keep them in both, especially as this is kind of the introduction to graphing this sine function. So now let me fill this table up. I'll do it in fast forward fashion. And then as I fill the table up, we can actually, take the outputs and put them in on the right hand side. So, what would the answers be? Okay, so I'm going to do that for the entire kind of unit circle. And then I'm going to start, and then again, if I do rotations and I continue on. Now, by the way, you can also go in the negative direction, right? So you can say negative 30 degrees, negative 45 degrees, and so on. And what that would mean is that would simply mean that we're moving in this direction. So we're going negative in this, but those values are still the same, okay, within there. So it doesn't matter which direction you go. Okay, so I'll be right back. Okay, I'm going to fill out the table for you. All right, so what I did was I just simply filled out, okay, your input, which is basically the angles, and I'm just going to go all the way around the unit circle, so creating those angles, and then I'm going to swing back again. So notice I went from 0 to 30 degrees, 45 degrees. Now, you can fill in other values if you want. You can fill in 15 degrees, you can fill in 75 degrees, whatever it is that you want. But the unit circle, we know what the sines and cosines are there, right, from the ratios. It's kind of something that we're familiar with. So that's why I just stuck to these. And then once we graph these out, you'll see what kind of a nice, beautiful pattern it will create, this periodic function, okay, that we will have. So, I started with 0, and then I went all the way to 360, and then I started repeating. So I went 390, which is, in radians, 13 pi over 6. And, and then you can continue on, and you can keep adding on, so 415, and so on, okay, if you wanted to, keep going around this unit circle. But there's going to be a repetition, right, that you have, and it's going to turn out that, after this point, there's no need for you to keep going and finding out, because it is a periodic function. So it just keeps repeating from there onwards. All right. Okay, so let's now fill out all of these values. Okay, so for sine, I'm going to do that. And I'll, do it in fast forward fashion for you. And then we're going to take this table of values and we're going to plot it. I'm going to bring back decimals. You can do it by hand as well, and you can start plotting these things out for yourself. So maybe that's what I'll kind of initially do. And then, okay, we'll plot it on decimals to see this function. Okay, so let me be right back. All right, so welcome back. Okay, so what I did was I just took the values of sine at that particular angle. Okay, so from 0 all the way to 360 and on. And I just filled them in here. And now, once we have these, okay, now we can start to try to see if we can plot this function. Just as we did with all the other ones, with a line, with a quadratic, right, with exponential or anything else. We kind of always started with this table of values. So now that we have all of these, and if I wanted to draw out, so I'm going to kind of try to draw the axes in here. Okay, so let's say I have something like this. I'm going to try to plot it out like that. Okay, let me maybe shift it a little bit. Okay, a little bit down, just so it doesn't interfere with our table of values. So this is your output. So this is your function. So this is your y, right, which is basically sine of the input x. Okay, or you can put theta there if you like. And what happens is, if I keep it, so if this is my x, okay, or my angle theta, if I start plotting these in here, so my values for x, okay, I can designate these, so 0, 30, 45 degrees, 60 degrees, or I can put them in radians, okay, so I can say 0 or pi over 6, pi over 4, pi over 3, pi over 2, okay, and so on. So I'll keep them in degrees for the moment because I feel that students are a little bit more familiar with that at first. Okay, so within here, so let's say our independent variable is the angles. So, so this is 0 degrees, and then it goes 30 degrees, 45 degrees, and so on. So I'll kind of put it within here, okay, and I'll break this down a little bit. So let's say this is 90 degrees, okay, I'm going to try to see if I can squeeze this in here. This is 180 degrees, let's say 270 degrees, all right, and then this is 360 degrees. And afterwards, I'll plot these up in decimals, okay, so that you can see this table of values in its entirety. And then we'll plot those points, and then, we'll also plot the graph itself, and you'll see that it's going to be this beautiful pattern, okay, that you have that emerges. But we can start with here. So notice, if I go at these values, what I notice is my kind of highest point is 1, which happens at 90 degrees. And then my lowest point is -1, which happens at 270 degrees. So if I was plotting this, let's say, this right here, let's say this was 1. And I guess this, let's say 1, 2, 3, 4, 1, 2, 3, 4. I'm trying to kind of do it symmetrical. So I start off at basically sine of 0, right? I know that at 90 degrees, so it's supposed to be 1. At 180, it's back to 0. At 270, okay, notice that it goes to -1. And then it comes back to 0 again. And now the values at 30 degrees, and then the values at 45 degrees and 60 degrees, right? So what happens is, well, at 30 degrees, so it's about right here, which is half. That's 1/2. Then it goes, okay, then it's square root of 2 over 2. Okay, you can do that right there. So it kind of starts looking like this. And then it starts coming down, right? So then it goes like that, okay, within here. And again, so within here, so it will start going like this, all right? And then it starts coming back down. And notice this beautiful pattern that it now starts to create. So it starts to create, I'm going to try to connect these up, okay? And you have this pattern. I mean, I'm not doing it justice here, but it kind of looks like that. And I guess my scaling also of the degrees isn't perfect, so that's why I'll try to bring back decimals. But those are kind of the points that we have. And then after this point, it starts to repeat. So now that's actually what's going to happen is it's going to start to repeat, which means that basically, from here to here, this is your one cycle. So that's the cycle from 0 to 360 degrees, right? And then, so that's your one cycle. So the period that we have, if we wanted to be able to identify these, right? So let's say if I bring all of this back here, I'm going to try to bring all of these, and I'm going to copy it. And I'm going to bring it in here so we can kind of define it on this chart. So that's what we will have in here. So if you do this, so what is the period? Well, the period is the length of one cycle. And if we actually graphed this further, both in the negative direction, so in the negative degrees, and we kept going in the positive degrees, you would have noticed that it's continuously repeating. Maybe let me bring decimals so that you can see it. So if I bring decimals within here, okay, and I plot this, so we have y is equal to sine, okay, of the angle. And I'm going to put x as my input. Notice that, look how beautiful this looks. So you basically have, so we started here at 0, so I'm going to shift it back in here. Now, your angles within here, so what Desmos is doing, it's not plotting degrees, it's plotting radians. So it's plotting radians on the x-axis, on the independent axis. That's what it's trying to do. So for instance, if you notice, like if you look at the peak here, notice it's pi over 2, right? Because that's 90 degrees, that's the furthest point up. And then it's 1, because the answer of sine of pi over 2, or sine of 90, is 1, right? And then you see the same thing. So for instance, notice here, it's pi, right? Pi is 180 degrees. And then if you keep plotting these, notice this is 3 pi over 2, right? And then this is 2 pi, which is 360 degrees. And now, once you have that, right, you notice that, oh, wait a minute, after that, it just keeps repeating. So there's an actual repetition within here. So maybe what I'll do is I'll try to capture this. Let me maybe hide this away, okay, and let's try to capture this. Okay, I'm going to kind of capture it like this. Let's break it down, and I'm going to insert it into our notes. Okay, so let's say done. Okay, and let me go back into our notes so that our view is going to be a little bit nicer, okay, than we had. Okay, so here it is. But please remember that your x-axis is in radians, and this is what I mean. Most graphing tools will display for you in radians. They may not display for you in actual degrees, but that's not a big deal, right? You know, you should be comfortable with that. And here, you know, so if you were looking at one cycle, this was basically just one cycle. From here to here, it's one cycle. After that, it's just repeating the exact same cycle. So again, so from here to here, notice it's going to repeat exactly the same thing. And this also goes in the negative direction as well. All right, so it would have been repeating those patterns. So that's, okay, now we can kind of take this and plot it up in here. So if we're talking about period, so period would have been the length that we have. So that would have been from here to here. Okay, let's see if it's going to do a nice arrow. Not, okay, so that's okay. So let's do that. So that is, so this is the first, this is a cycle, right? And this is the period. So the period is equal to 360 degrees, or it's equal to 2 pi in radians. That's the length of our periodic function. And then after that, it just keeps repeating and repeating and repeating. All right. So what else? Midrange. Well, midrange, notice the mid-range of this. So that actually happens, and let me maybe do it here in blue. So the mid-range is the middle distance, right? It is, so if you remember what the mid-range is, it's your maximum value plus your minimum value. So it's 1 plus -1, which is 0, divided by 2, okay, which is that. So my mid-range is basically 0 here, all right? Okay, so that's what that 0 is. Now, my amplitude, so the amplitude was supposed to be the height, right? So that's the height, okay, from the mid-range. So your amplitude is equal to 1. That's your amplitude. That's equal to 1. Now, sometimes, you know, people say, well, in this direction, it's -1. So that's true. Okay, in going in the negative direction, it's -1, but amplitude is always the absolute value. So it's always the absolute value from the mid-range. So it doesn't matter if you go down or up, okay, it's still going to be equal to 1. Okay, so that's kind of the height that you have. Now, the maximum and minimum values, well, those ones we know. So the maximum value was 1, the minimum value was -1. And those are your peaks and your troughs, right? So those are your peak, okay, and then your troughs, kind of your valleys that you have, and then your peaks that you have. That's what you have in there. What's the domain of this function? Well, the domain is all the possible inputs, correct? Well, the possible inputs that you have are limitless. Okay, so sine exists, so sine of the angle exists for any angle that you have. Now it will repeat, right? So sine of, let's say, 480 is going to be a repetition of the first angle, okay, that you had. But the domain is basically, so if we wanted to have the domain is any real number. There are no restrictions at all on the domain for the sine. And in fact, the same thing happens for cosine. And you'll see that cosine, once you understand sine, cosine is just basically a shift. And I'll graph that for you in a moment as well. Now the range, well, the range is all the possible outputs. So for this function, the possible outputs within here, so for our range, maybe I'll write the range in here, our output range, okay, so that's all, okay, the real numbers. However, we do have a restriction, right? It is basically between -1 and 1 for this sine function. It doesn't go any higher and it doesn't go any lower. It's always in between there. So that's our range, right? It just keeps kind of waving around in there. Now the zero crossings, well, those zero crossings happen, okay, so they happen here, they happen here, they happen here. Notice the zero crossings just keep repeating. And what do you notice about the zero crossings? That's when sine of the angle is equal to 0, right? Well, when is the sine of the angle equal to 0? The sine of the angle is equal to, so your zeros that you have will happen at 0 degrees, at 180 degrees, at 360 degrees, right? Okay, and and then it continues on. So if you wanted to write it out in radians, okay, so it happens at, okay, so you have basically at every single pi interval. So this would have been 0, this is pi, this is 2 pi, would have been now 3 pi, right? 4 pi, okay, and so on. So that's when those things actually happen, and you can designate that. Sometimes we write it as n pi for n, equals to 0, 1, 2, and so on. So that's when your zeros happen, your crossings. So that's when sine is equal to 0, okay? So that's what you see right there. So that actually answers all of these, okay, for this kind of periodic function. Now, how does sine differ from cosine? Well, remember that sine and cosine, if you go back into your unit circle, sines and cosines actually had the same values, right? Except, when you were doing your cosine and your sine, your cosine in the beginning, so it started off at 1. So again, if I highlight this and I go around this unit circle, around the angles, so notice that the sine here was 0, but cosine was 1. In here, the sine was a half, but your cosine was 3 pi over 2. Here, sine and cosine were equal to each other, right? Here, right here, sine was now 3 pi over 2, and cosine was a half. Right here, cosine is 0. So if you're going to be graphing this out, so what you will notice is, if you were trying to plot it, so instead of starting at 0, so if you were plotting your cosine, I'm not going to do another table of values, but I'll just try to show you. Well, your cosine is going to start at 1. Okay? And then it's going to, okay, so as you're kind of going through this entire thing, so as you're plugging along, okay, so now your cosine all of a sudden, okay, so if you're moving through, so it will kind of start shifting and looking like this. Okay, so it's going to start shifting, okay, and looking like this. So it's going to go down, okay, and then right here, it's going to go up, okay, and then it's going to come back right here. Okay, so your values that you have, okay, that's going to be your cosine values. And you can plug them into a table of values, and you can write them out Okay, so within here, so if you instead, okay, had sine of, and I changed this up, so if I change this, and instead of having sine, I would have put cosine, okay, of this. So I'm going to write them in pink right beside it. So here it would have started at 1, right? Then instead of being a half, it's going to be 3, okay, over 2. This is going to be identical. This is going to be a half. When sine is 1, cosine is going to be here is 0, and so on. So it continues in that pattern. So that's what happens within here. So, you know, it's kind of interesting that that's what you have. So it would have been this, okay, right here, they're the same. Right here, it's kind of, you know, half. Then it's here, okay, and then it continues onwards. Let me plot it for you, okay, on decimals, for instance. If I go back in here, and I'm going to try to plot it on the same graph here. So let me do this, and then let's say y is equal to cos of x. And notice, you know, so the blue as it popped out, it looks very, very similar, right? So it has the same amplitude, it has the same mid-range, right? It's going to have the same domain, it's going to have the same range. So pretty much everything is the same. And the only thing that happens is actually sines and cosines are just a shift. So notice if I take cosine, which is the blue, right? And then the red, notice the peaks. Look how far off the peaks are, right? So those two peaks. So if I just took the cosine and I did a shift, I did a translation, which we're going to talk about transformations of these. If I did a translation, right, of the cosine by 90 degrees, then you would notice that it would line up. Now, if you remember translations or not, so you can stick them in here. So notice what I'm going to do is I'm going to translate it. So minus, and I'm going to say, let's say pi. So I'm going to put pi in there over 2. And look at that. It lines up exactly with the sine. And that is true. So sine x is equal to cosine of x minus 90 degrees. And I put it as radians because we're plotting here in radians. Okay? So I'm going to go back in here, remove that, and notice that's your cosine. And you can plot all the points up again. I encourage you to take decimals, play around with it. We're going to do quite a lot of playing around with transforming these. So making amplitudes bigger, right? Compressing them, stretching them, you know, and shifting them around. So translating, you know, up, down, okay, to the side. So you'll notice that. And that's going to be in transformations, which you've actually done with a lot of different functions. So that's the introduction to your sine and your cosine functions. And, you know, they're repeating, and it shouldn't surprise you at all, because if you look, of course it's repeating, of course it's a periodic function, because as you kind of shift this over, right, and no matter what you do, it's like a clock, it just keeps going, right, in both directions, and it just keeps repeating. All right, thanks for watching. We'll see you in a future video. Bye, everybody.